Okay, today we are actually starting Algebra 2 type stuff. Everything up until this point has been a review of Algebra 1, and what we're doing now is really getting into more of Algebra 2 work. And again, hopefully what you're going to see today is review. It might not look like review, but hopefully you know how to do it. We are going to start multiplying polynomials today. We'll talk more about polynomials as time moves on. But this is like the heart of Algebra 2. So we're going to spend like 2 whole weeks just multiplying and dividing polynomials, multiplying and factoring. So hopefully you saw the stuff in Algebra 1, but if you haven't, I teach it the same way I always teach it. I teach it as if you didn't learn it the first time, okay? So we're going to start with a little bit of a review of properties of exponents. So these first 3 questions just review some basic properties of exponents. And so before we start, I just want to refresh your memory. If I have x squared, I have some vocabulary. This, the x is what we call the base. It's definitely stuff you should write down. If I write stuff down, you should write stuff down. And 2 is called the exponent. The 2 affects what is directly just under and a tiny bit to the left, okay? So just directly under it. And what that exponent does is it tells you to repeat. It tells you to repeat the base that number of times. So if I had to expand x squared, then I would say that 2 is saying repeat the base 2 times. So we would write it out as x times x. And it repeats, it's just a product, okay? That is the meaning of an exponent. It says repeat whatever is under it that number of times as a product. And so, like on number 1, if I wanted to, and we call this expanded form, okay? It's expanded because you can see it's clearly expanded. It's written out, okay? So if I wanted to expand x cubed, what would I write? X times x times x, sure. And of course, what operation is between the x cubed and the x to the 4th? Add, subtract, multiply, divide. Multiplication. Yeah, there's nothing there. It always means multiply. So now we want to multiply. If I were to expand x to the 4th, what would I write? X times x times x times x, sure. X repeated 4 times. And then if you wanted to recondense this would be x repeated how many times? So Lord of mercy, expanding everything would take forever, right? We don't want to do that. And so we have shortcuts. However, you could always expand and you will always get the right answer. It just takes you longer to get there, okay? So what's the shortcut? How do I get 7 with just x cubed times x to the 4th? What do? Add the exponents. That's it. If they have the same base, then we add the exponents, okay? Write that down. That is the rule of the day. If things have the same base, then we can add their exponents. If it's a product, okay? If it's all multiplication. All right, so I want to expand number 2 in the same manner. This one's slightly different, but here we have y to the 5th, and it's being squared. So it's saying repeat 2 times. What is it telling me to repeat? The y to the 5th. Yeah, the whole thing, because what's directly under the 2? The parentheses. So it's saying repeat everything in the parentheses 2 times. Well, that would be y to the 5th times y to the 5th. Now, these have the same base. So what does that mean? Add the exponents. If they have the same base, you add the exponents, and that gives you y to the 10th. Well, very good. So you can always write it out and then expand, and then, add the exponents, which works just fine. And so, But is there a shortcut? 5 times 2. Yeah, the product. If you have this situation, this is called a power to a power. If you have a power raised to a power, we have y to the 5th being squared. Power raised to a power. Then we get to multiply the exponents. And again, if I'm writing this down, you should be writing this down. I don't do this for my health, ladies and gentlemen. I know this stuff, all right? And so you ask, but why? I grade your notes, that's why. Okay, so we can just multiply. The base stays the same of y, and we can multiply 5 times 2 and get 10. All right, so these are the 2 rules we're going to be using a lot today. All right, now I want to talk about number 3. Number 3 is very special. What is this? What is this for affecting? The base. What is the base? Yeah, -3. That 4 affects everything in those parentheses. And so it's saying repeat the base 4 times. So if I were to expand that, that would be what? -3 times, -3 times, -3 times, -3. So I would expand that. I would write the entire base out 4 times. And that would give me what? 81. Positive or negative result? Positive. Why? How do I know that it's a positive result? Even number of negatives gives us a positive result. Okay, and that's really important that we understand that because we want to be able to do that quickly, right? And then, of course, 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. So be very careful. The reason I say be very careful is because the most common algebra mistake is -2 to the 4th. What is that telling you to do? -2 to the 4th. What is the exponent affecting? Just the 2. The thing that 4 is affecting is what is directly underneath it, which is the 2. Is it saying repeat the negative 4 times? No, it is not. The negative is going to hang out in front, and this repeats the 2 4 times. What's the result? -16. What's the difference between these 2? Parentheses. Okay? Be very careful, ladies and gentlemen. Know what that exponent affects, okay? This is the number 1 mistake made in algebra, period. Okay? So know what that means when you have that exponent there. Okay, so these are our 2 rules we're talking about today. Same base, add the exponents. If you have a power raised to a power, we are going to multiply the exponents. Most of our exponent problem exercises seem very, very complicated, and really it's just because we haven't done enough of them, all right? It takes a long time. I think the hardest part about properties of exponents is that there are so many different ways to do the problems that we get confused, okay? Because we can do it a different way every single time and still get the same answer, okay? If you want to expand everything, you can. And then recondense it. You can do that. That's not the fastest way, but it'll work every single time. So we want to use properties of exponents to simplify the expression. And those properties are just what we talked about. Same base, add exponents, or power raised to a power, we multiply the exponents. I think the easiest thing that I like to do is I don't like seeing the parentheses. When we have a set of parentheses and next to another set of parentheses, what operation is in between? Multiplication. All of this is multiplication. And so what I like to do is write these things without those parentheses, because I think the parentheses actually impede our understanding. So what I'm going to do is I'm just going to drop all these parentheses. We have all of these things that are just being multiplied together. This is E, times f squared times e squared times f. Everything is just a giant product. The reason that I'm separating these things with multiplication is because I think it's easier to see all the different things we're looking at. The other thing you want to understand is everything has an exponent. What's the exponent on e? 1. There is always an exponent of 1. Always, always. And I encourage you to write those in because A, we don't want to forget that. We need it there to be able to add the exponents. So now I want to look for, if we have the same base, what do? Add the exponents. That's the rule. We've sort of written everything out. And now I have the same base of e. What's e to the first times e squared? E to what power? The third. Yes. All we do is add the exponents. 1 plus 2 gives us a power of 3. We have f squared times f to the first. What's that going to be? F to the third power. Same base. Add the exponents. 2 plus 1 is 3. You can write e cubed times f cubed, or e cubed f cubed means the same thing. So whether or not you put the multiplication dot in there, same thing. All right, with or without the dot, same thing. I want to do letter B here. And what case is this? Is this the same base add exponents or something different? Power to power. Yeah, this one has a power raised to a power. I'm going to repeat this one. You don't have to do it this way, but I'm going to write this one out, okay? So I'm going to write this out 3 times, just this first time, so you can see how it would work. I'm not going to use parentheses. What is this 3 affecting? Everything in the parentheses. So I'm going to write everything in the parentheses 3 times. Negative xy cubed times negative xy cubed times negative xy cubed. Again, everything is being multiplied, so I can even put in some more. This is really, negative 1 times x times y cubed. Negative 1 times x times y cubed. And the reason I like doing this is so that you can see everything is individual. All right? Everything can be broken, sort of separated, okay? And this then is x to the first power. They all have their own little exponent.
So that'd be x to the third.
Yep.
A times y.
Yes. Mm-hmm. And is it a positive or negative result? Negative result. Negative 1 times negative 1 times negative 1 is negative 1. It is a negative result. And again, x has the same base. Same base, same base. So that's going to be x to the third power. 1 plus 1 plus 1 is 3. And then y has the same base, same base, same base. Keep the base. Add the exponents. What do we get? 9. 3 plus 3 plus 3 is 9. Okay? Do you have to write it out like this? Heck no. If you can get the answer right off, fantastic. If you can't write it out, fantastic. I don't care how you do it. Okay? Again, everything here in letter C is connected by multiplication. So I'm just going to expand, sort of separate these things with a dot, just so we can see them clearly. G times h cubed times k times g to the 5th times h times k cubed. Does g have an exponent? Yes, it has its own little exponent of 1. Each thing is going to have an exponent. Even these negative 1s had an exponent. All right, so now I can look and say, hey, which things have the same base? I got a couple of g's. They have the same base. What do we do to their exponents? Add them, and what do you get? G to the 6th. Okay. H cubed times h to the first gives you h to the fourth. And k to the first times k cubed gives you k to the fourth. Good. Same base, add your exponents. All right. I am totally okay with writing out something 3 times. But here we have the same situation where it would say to repeat something 4 times. You absolutely could repeat what's in parentheses 4 times, but boy, that's monotonous. I don't really want to do that. So what I am going to do is sort of change my notation just a little bit. What is the 4 affecting? Yeah, and just this set of parentheses, not this front set. So I'm going to write this as c times d to the 4th. That first set, I don't really need those parentheses. They're not too helpful. But this second set of parentheses is important. And I'm going to talk about this is a -1 times c squared times d cubed, and it's all to the 4th power. So I don't want to have to write it out 4 times, but you could if you wanted to. It'll always work out correctly. Instead, I'm going to write things so that I have an exponent on every little thing here. So you'll see I had that -1 to the 1st power. And now, what situation do I have here? Is it same base, add exponents? Yeah, this is power raised to a power. Power to a power. What do we do? Multiply those powers. All right, so I'm going to multiply my powers together, which is why I wrote everything with its own little exponent. So I'm going to multiply all of those powers. Now, that's going to be -1 to the 4th power times c to what power? 8. How do we get 8? Yeah, 4 times 2. Very good. And then d to what power? 12. How do we get 12? 3 times 4. 3 times 4. Okay. And now we're looking for same base. If things have the same base, then we can add their exponents together. Oh, you know, he is not here. Thank you. Does this -1 base have a friend? No. So he's going to say -1 to the 4th power. Here, c to the 1st times c to the 8th is c to the 9th. D to the 4th times d to the 12th, d to the 16th. And what is -1 quantity to the 4th? The favorite answer is 4. It's not 4. What does it mean? It means -1 times -1 times -1 times -1, which is just a 1. Positive 1. Do you need to write the 1? Okay. Are there other ways to do these? There are tons of different ways. I can think of 5 offhand. Okay? So, lots of ways to do these. All right, this is the important part. Looks complicated, but it's really not. We are finding the product. What does product mean? What does product mean? Ladies and gentlemen, what does product mean? It's the answer to a multiplication. Yeah. Answer to a multiplication problem. So we are multiplying. What do we need to do with letter A? Distribute. Yeah, this is 3x times this whole group. You know how to do this. We've been doing this for months now. We are going to distribute. The difference is now we're also combining properties of exponents. This I'm only going to write out once or twice. We're going to multiply 3x times 4x. We're multiplying them together. Well, that would be 3 times x times 4 times x. What is 3 times 4? 12. And then x to the first times x to the first is x squared. X to the second. Same base, add your exponents. All right? Then, what's 3x times negative 9? Negative 27x. That's it. You know how to do this. All right, letter B. Again, we are distributing negative 1/3 x squared that I need to distribute to both terms inside the parentheses. And so again, this is really negative 1/3 times x squared times 9 times x times y. It's all just being multiplied together. You're going to multiply the things you can't. What's 1/3 of 9? 3 with a negative, so negative 3. Here we have x squared times x to the first, which is x to the third. And y doesn't have any friends, so it just stays y. And we're going to do here. What is negative 1/3 times negative 6? What is negative 1/3 times negative 6? What's negative times negative? Positive. Okay. What's 1/3 of 6? 2. 1/3 times 6 is 6 divided by 3. 6 over 3, which is 2. Okay. And then we have x squared times y. So x squared y. No, we cannot combine them. How come you can't combine these two terms? Grace.
Because you have an x cubed and an x squared, and they're not the same exponent, which means you can't combine them.
So they're not the same exponents. They have to be exactly identical exponents in order to combine those like terms. All right, so a little bit faster now. I'm going to take negative 1/4 jk squared and distribute to all 3 terms. We're going to multiply the numbers together, multiply the j's, and multiply the k's. So I'm going to ask you, what is negative 1/4 times 8? Negative 2. This is, if you will, j to the first times j cubed. What's j to the first times j cubed? J to the fourth. And then we have k squared times k squared, which would be k to the fourth. Moving to my second term here, I have negative times negative, which is positive. I have 1/4 times 2. What's 1/4 times 2? Yep, that'd be 2 over 4, which reduces to 1/2. So we get 1/2. We have j to the first times j squared. What's that? J cubed. We have k squared times k to the first, which is k cubed. And now on the last term, again, I'm just multiplying each little thing together. What is negative 1/4 times 5? Negative 5/4. Very good. Negative 5/4. What's j to the first times j to the first? J squared. And k squared times k cubed? K to the 5th. Any questions thus far? All right, last one. All right, 2st times the quantity 3st squared minus 5 minus 3s times the quantity st cubed minus 4t. So what do I need to distribute? Two st. That's right. Good job. I'm going to distribute the 2st. Do I distribute the 2st way over here? No. Okay. So we have two things to distribute. We're also going to distribute the negative 3s to both terms here inside the parentheses, but we'll do that in a second. What is 2st times 3st squared? 6. 2 times 3 is 6. S squared, very good. S times S is S squared. And then t to the 3rd power. Very good. Remember, these all have their own little exponents of 1. What is 2st times negative 5? Negative 10st. Very good. Now distributing the negative 3s. Again, that's s to the 1st. So negative 3s times st cubed gives you what? Negative 3s squared t cubed. Very good. And then negative 3s times negative 4t is going to give you positive 12st. Very good. Are we done? No, we do have some like terms that we can combine. Again, like terms have to have exactly the same exponent pattern. So I have 6s squared t cubes minus 3s squared t cubes. Which does that give you? 3s squared t cubed. And then I have a negative 10st and a positive 12st, and those would combine to give you positive 2sts. Very good. All right, ladies and gentlemen, do you have any questions for me? Really, this just takes a little practice.